everyone, welcome to our cafe. We sold various of beverages. Today, I would like to analyze the amount of beverages that we sold in 3 days. Since we opened Sunday, Monday and Tuesday, I have recorded 3 types of beverages, which is latte, cappuccino and green tea in report books in these 2 weeks. I would like to know the amount of each beverages that we sold. Did you have any idea?
I think I have one. You can arrange the data in the form of matrices. Let me show you how to do it. First, arrange your data in the form of row and columns. Now, you can get 2 forms of matrices, matrices A and B. Add your matrices A and B together. Easy, right? Now you know the amount of each green tea, latte and cappuccino in each day, Sunday, Monday and Tuesday.
Wow, that's such a good idea. Can I know more about matrices? I think I have to use it on my daily life.
Of course. Let's listen to the explanation from Mrs. Taki.
Hello everyone, it's Mrs. Taki here. Do you guys know what is matrix? No worries. In this video, I will explain about types of matrices and algebra of matrices. Let's start with types of matrices. In this video, you will learn in about 8 types of matrices. Okay, the first matrix is column matrix. Column matrix is a matrix with order n by 1. These are the examples of column matrix. As you can see here, there is only one column in matrix A and matrix B. The second matrix is row matrix. Row matrix is a matrix with order 1 by n. As shown by the examples here, you can see in matrix C and matrix D, there is only one row of matrix. Square matrix is a matrix where it has the same number of rows and columns. For example, matrix E has 4 rows and 4 columns, which resulting to a square matrix E with order 4 by 4. Same goes to matrix F, which has 3 rows and 3 columns. Zero matrix is a matrix which every entry is 0 and denoted by O of zero matrix. See? All are zeros, right? The fifth matrix is diagonal matrix. Diagonal matrix is a square matrix which non-diagonal entries are all 0. Here are the examples. If you observe it, for matrix H, the diagonal entries are 6, 4, and -5. While for matrix I, the diagonal entries are 8, 7, 9, and -5. The sixth matrix is identity matrix. Identity matrix is a diagonal matrix where all its diagonal entries are 1 and denoted by I. Here are the examples of identity matrix. The first one is identity matrix with order of 5 by 5, while the other one is identity matrix with order of 4 by 4. As you can see here, the number of rows and columns have to be the same. Lower matrix is less than its column J equals to 0. As you can see here, the value of entries other than those in the triangles are 0. And if you observe it, those entries which its value are 0 are the entries that its row I is less than its column J. The last matrix is upper matrix. Upper matrix is a square matrix which the entries that its row I is more than its column J equals to 0. As you can see here, the value of entries other than those in the triangles are 0. And if you observe it, those entries which its value are 0 is the entries that its row I is more than its column J. That's all for the types of matrices. Now, let's move on to the algebra of matrices. First of all, let's discuss about multiplication of matrices. You must be wondering, how do we do multiplication of matrices, right? In order to do multiplication, the product of 2 matrices A and B can only be done when the number of columns in A is equal to the number of rows in B. Look at this. These are 2 matrices A and B with order n by n and n by q. As the number of columns of the first matrix and the number of rows in second matrix are the same, multiplication can be done. Thus, the outcome order of the product is n by q.
An example of multiplication of two matrices of this order, we can know that either both matrices can be multiplied or not. So we must look at the column of matrix A and the row from the matrix B. So if it is equal, then both of these matrices can be multiplied. So we know that we must find matrix AB. To know the order for the product matrix, we must see the row of matrix A and the column from matrix B. And we know that the order for matrix AB is 2 by 3. So next, for our working in multiplication. So in multiplication, we know that to find A11, we must times the first row of matrix A with the first column of matrix B. So the working will look like this. 5 times with 2 and plus 1 times with 1 and 5. So for the multiplication with the next column is 5 times 3 plus 4 and 1. Then if it looks like this. So you just need to simplify all of that and you will get the answer for this question.
Here are two properties of matrix multiplication, which is associative property and distributive property.
For the example 2, associative property, question is show that A bracket BC equals to AB bracket C. So all of the matrices that were given is in order 2 by 2. Next, we can separate the equation into left hand side and right hand side. For the left hand side, we can see that BC is in the bracket, so we must solve the BC matrices first. So we multiply B matrix with C matrix and we will get the answer that is 6, 16, 12 and 30. Next, we can multiply matrix A with the matrix BC that we have find before this. 2, 4, 6. For the right hand side, we can see that matrix AB is in the bracket. So we must find the matrix AB first. And we will get the answer for matrix AB. And next, we multiply matrix AB with C and we will get the answer for it for matrix ABC. So this shows that left hand side is equal to right hand side. For the example 3, distributive property. So we show that A bracket B plus C equals to AB plus AC. Same like the before example, we divide the equation into left hand side and right hand side. So for the left hand side, we can see that B plus C is in the bracket. So we must find the B plus C matrix first and we will get the answer. And then we multiply the B plus C matrices with the matrix A and we will get the answer for the A bracket B plus C matrix. So for the right hand side, which is AB plus AC, we must find the AB matrix first and we will get the answer 26, 10, 32 and 11. And next we find for the AC matrix, we multiply matrix A and matrix C together. And we will get the answer 21, 55, 18 and 52. AB and matrix AC. And the answer for addition matrix AB and AC is 47, 65, 50 and 63. Thus, we can see the left hand side equal to right hand side.
Now, let's talk about transpose of matrix. Transpose of matrix is interchanging of rows and columns of matrix.
For the transpose matrix, we know that transpose means interchanging between row and column. So as we can see, there is matrix A and matrix A, the order for matrix A is 1 by 3 and for the A transpose is 3 by 1. So there is interchanging between the row and column. So for the next example is matrix B, the order for matrix B is 3 by 3 and the matrix for B transpose is 3 by 3 because so in order for we to get the B transpose, we must interchange the first row of matrix B with first column of matrix B transpose. Then we will repeat the same thing for another row until we interchange all of the rows.
Here are some side notes of properties of transpose. That's all from me. Thank you for watching.